Right, so last section we'll look at in chapter 5, last section, chapter 2 is section 5, and it's on higher order inequalities. All that means is we're going to look at inequalities now that don't necessarily have an 1 as the highest exponent. You might have a 2, okay, or maybe even a 3. Right? We're not going to go super high because we got to kind of stick with stuff we can factor, because that's the whole key for solving these, factoring. All right, so let's start out by looking at something we've done before, okay, the projectile motion equation. Okay, I put it up there again and relabeled everything, but you should already have it in your notes from earlier in chapter 2. And if an object is thrown or launched and it's following projectile motion, this is the formula we can use to figure out how high the object will be based on how many seconds after it left your hand are we looking at? Is it like 1 second or 20 seconds later? How hard the object was thrown, okay, that's the initial velocity, and how high was the object when you threw it? Okay, did you throw it while you were standing on the ground? Or were you standing on top of like a building when you threw it? Okay. So that's the projectile motion equation. So our examples, it says a ball is thrown straight up from ground level. So if it says ground level, that means the initial height is what? Okay, 0. So you might think, well, if a person was throwing it like straight up, if they were 6 feet tall, wouldn't the ball be like roughly 6 feet when they release it? That would make sense. But let's assume that the ball is like maybe on some kind of device on the ground that is just going to like launch it straight up. So the ball is actually on the ground, and maybe there's something under the ground that's going to come up and hit it or something. All right. So the ball is being launched straight up from the ground, and it has an initial velocity of 80 feet per second. Okay, so let's just let's fill in the formula with what we have so far. So the height of the ball equals negative 16t squared. You never fill in for t unless they ask you, like, how high is the ball at 3 seconds? Then you fill in. The only thing I can fill in right now is 80. And Tori, where's the 80 going to get plugged in?
For v.
Yeah, for the v sub 0, the initial velocity. Plus 80t. Now on the end, you already mentioned this. The initial height is 0. So you don't need to put plus 0. Okay, so there's a formula. And in the next part, they're going to probably ask us to do something with that. When is the ball at least 64 feet above the ground? All right, so when is the ball at least 64 feet above the ground? So where would the 64 get plugged in? About, Rob?
The height?
Yeah, it's the height. And what letter in that equation represents the height?
S.
Yeah, we used S. So I'm going to do 64, and I'm going to go negative 16t squared plus 80t. Now, the question is not when is the ball exactly 64 feet above the ground. When is the ball at least 64 feet above the ground?
So, greater than or equal to.
So we want, if you think of it this way, this formula right here is the height of the ball. That's the height of the ball. And you want that to be at least 64 feet. So what symbol would I fill in here? Yeah, Justin?
Greater than or equal to 64.
Like this, that's a greater than or equal to.
Yeah.
So now that's saying that the height of the ball is less than 64.
No, other way around.
Yeah,
My bad.
because of the way we wrote it, you'd want it that way. Or you could do it this way. The height of the ball, now you could use is greater than or equal to 64. So you can do it either way. But if the 64 is on the left, it's got to point towards the 64. Okay? It's got to point towards the 64 either way, no matter which way you're in. Okay, so let's graph that. So I'm going to graph what's on the left in y1. I'm going to graph what's on the right in y2. I'm going to use this one. It doesn't really matter which one you use. But let's put, if you have anything else in there, just clear it. All right, so 64, negative 16x squared plus 80x. Now, I'm going to have a horizontal line at 64. Y equals 64 is a constant function. So I got to go at least 64. But I bet the ball goes higher than that. So let's set the height. Maybe we'll go with 100. Now, x is taking the place of t. So x represents time. Chris, could I have negative 10 seconds for time?
No.
No, what's the smallest value I should do?
0.
Yeah, 0. Now, how long is it in the air for? That's x max. We don't know. So let's just leave it at 10 and see what happens. The object is not going to go underground, so negative height doesn't make sense. And I'm guessing it doesn't go higher than 100 feet. I don't know, maybe that's wrong. If it's wrong, I'll come back and adjust it. So there's my 64 feet. And okay, I think I can see the maximum there. I'm just going to set it a little higher, just in case it goes off the screen a little bit. I don't think it does. So now, no question, I can see the maximum. All right, so now they want to know, when is the ball at least 64 feet above the ground? All right, so let's look at the picture. What do you think I'm going to have to do there? Yep. Yep, we're going to find both intersection points. So I'll do, let's see. All right, I'll do the one on the right. If someone else that has their calculator can find the one on the left, just put your guess closer to the left. So pick a point on the blue, pick a point on the red, and then put your guess closer to the one you want to find. So it looks like it's 4. So that intersection point is 4, 64. We already knew the y value was 64, right? Because that's where we put a line, at 64. So this one is something, 64. Does anyone have the other point yet? 1, okay. So remember, the x represents time. So what times would you have to be between for the ball to be at least 64 feet? Chris?
1 second to 4 seconds.
And could you equal 1 second and 4 seconds?
Yeah.
Yes, because at least means, like if I said I have at least $10, that means I have 10 or more. I could have equal to 10 or more. So equal to 64 or more. All right, so when is the ball 64 feet above the ground? Between 1 and 4 seconds. And I'm just going to put including the 1 and the 4. Or you know what? You could actually just write it's a closed interval. Between 1 and 4 seconds, closed interval. Okay, because a closed interval means you reach the endpoints. An open interval means you don't. So you could just write it that way too. Any questions on that? So this is an example of solving a quadratic inequality, okay, using the calculator. All right, so now they want us to figure out how long the ball is in the air for. So if the ball is in the air, what does that mean about its height? As long as it's still in the air. Yeah.
The height is more than 0.
The height is more than 0. So let's just take the equation we just had. So the height of the ball is negative 16t squared plus 80t. And as long as that is greater than, well, technically it's greater than, because if you equal 0, then the height, that means your ball's back on the ground. So. Okay, so let's see if we can solve this. Does anyone see on the left-hand side something that both of those terms have in common that I could factor out? Yep. 8. Yep. Even more. Yep.
You can divide 80 by 16.
16. Yep. So you can pull out a 16. Even more. Yep.
16t.
16t. Yep. And just because I like to have squared things positive, I'm going to factor out a negative 16t. If I factor out negative 16t from negative 16t squared, what does that leave me with? T. And if I factor out negative 16t from 80t, what does that leave me with? Yep.
Negative 5.
Negative 5. Okay. Now, here's, we got to use a little bit of, bless you, okay, a little common sense. You have two things being multiplied together, and it's greater than 0. What's one way you could multiply two things together and get a positive? Greater than 0. You could do a negative times a negative, that's a positive. Or, what else could you do?
Positive, positive.
Positive, positive. Now, only one of those situations makes sense here. Does anyone see which situation it's going to have to be? Yep, Kai?
Negative, negative.
It has to be negative, negative. Okay, the reason, t is time. Time is always greater than or equal to 0. So, no matter what your time is, when you multiply a number that's greater than 0 times a negative, this is always negative. Always. So there's no way that'll ever come out positive because time is positive. So if this is negative and somehow you want to get an answer greater than 0, then the question you have to answer is, when is t minus 5 negative? Because that could be negative or positive. Depends on what t is. If t is 3, it comes out negative. If t is 6, it comes out positive. So this one has options. The first one doesn't. First one is always negative. So, when is t minus 5 negative? All right, so just think about it like this. When is t minus 5 less than 0? As long as t is less than 5. So what that means is the ball is in the air for less than 5 seconds. It's in the air like 4.9 repeating. At 5 seconds, it hits the ground. And you know what? Don't worry about part B. I'm not going to do that because we're going to solve inequalities algebraically quite a bit in a minute. Okay, but I just wanted you to see how to do this one without using a calculator. And if you look at the calculator, that confirms it. If you look at the parabola, look at where it hits the x-axis. If you calculate the 0 or the root, 1, 2, 3, 4, it does happen at 5. Okay. So any questions on solving that one? All right, so not too bad because you were able to factor out a GCF from each term, and it didn't have a constant. Okay, if we had an initial height here, that would have messed us up a little bit because an initial height would have been just a number. You wouldn't have been able to factor out a t from just a number. Okay, so that would have messed us up. So how do we handle that when that happens? Like this. So we're going to make what's called a sine pattern. We're going to draw a picture to help us visualize what's happening. So every linear factor is 0 at exactly one value. Okay? These are examples of linear factors. X minus 3, y plus 5. Okay? Basically, any letter plus or minus a number. Now, you can't have x squared or x cubed. It has to just be a letter. It could be 2x minus 8. That's fine too. Okay? As long as the x is always to the first power. So what I'm saying is, for each one of these, there's exactly one number you could plug in and get 0. The first one, you would plug in 3 and get 0. The second one, you would plug in -5. The third one, you would plug in 4. Okay? But that's it. There's only one value that makes each one of those 0. All right? Here's a couple more. So the factor t minus 1. Where does that one come out to 0? If you plug in 1. T plus 4. Where does that come out to 0? At -4. So what that basically means is, if you think of it on like a number line, okay, and let's just go like this. Let me do the first one. So the first one is 0 at 1. 1 is kind of the dividing point. What's at the dividing point between positive results and negative results? So now that I know plugging in 1 gives me 0, if you pick numbers smaller than 1, something's going to happen. It's either going to get positive or negatives. If you plug in numbers bigger than 1, you're going to get the opposite, either positive or negative. Depends on the problem. But that's the whole key. We're going to find that dividing point where to the left of it, something happens, and the right of it, the opposite happens. Is there any question on that? That's the goal. So what we're going to do is we're going to make a number line, kind of like I did here, for each linear factor. So if your problem has 2 linear factors, you're going to make 2 number lines. If you had a problem with, I don't know if I have one with 3. I think I do later on. But if you had one with 3, you'd end up making 3 number lines. So we're going to draw a number line for each linear factor, and we're going to mark the 0. You don't have to put a big line like that. You could just put a dot, or you can put whatever you want. But we're going to mark where the number that causes it to come out to 0. And then we're going to check the sign in this section. In this case, any number to the left of that dividing line would result in a negative. Any number you plug in to the right of the dividing line would result in a positive when you evaluate using that expression. So that's what we're going to do. We're just going to split it into negative and positive. Okay, so let's start with that. Let's look at an example and see if we can just make our number lines. Now, the whole key to making this work is factoring. If you can't factor the problem, none of this works. You've got to be able to get the 2 sets of parentheses. Don't worry about that step yet. I would say leave a little bit of space from what you just wrote, enough to fit that. And if you want to copy it now, I guess you can, but I'm going to explain that when we get to it. Okay, so our first problem is 2x squared plus 9x minus 5. And they want to know where that is greater than 0. So it's an inequality, and it's a quadratic. So you can't get x by itself, if it was just something like this. Not as easy as just dividing both sides by a number. Okay, so first thing we have to do is factor what's on the left. If I'm asking you to solve this with a sine pattern picture, then I'm going to give you something that's factorable. Okay, so let's start with the first term in each set of parentheses. What does my first term have to be? Rob? 2. Anything else with the 2? Because I want the two things that you give me have to multiply together to give me that.
2.
Yes, 2, perfect. 2x and 1x. Yep. You don't have any options. 2 is a prime number. Okay, so it's got to be 2x and x. Next thing is I have a positive middle and a negative constant. So Jacob, what kind of signs do I need when the middle is positive and the constant is negative?
Positive and negative.
Yep. Now I'm just doing it in the order he said. We might have to switch that. We'll see what happens. And now two numbers that multiply to give me 5. Again, 5 is prime. So Haley, what would be the two numbers that multiply to give me 5?
5 and 1.
There. So I'm just going to try it in the order she said and see what happens. So I get 2x squared minus 2x plus 5. Minus 2 plus 5 is not 9. So what should I do here? Jark?
Switch the numbers.
Yeah, switch the numbers. Okay, don't switch the signs yet. Let's switch the numbers. So let's try 1 and 5. We're closer. So now we have 2x times negative 5. That's negative 10x plus 1x. Negative 10 plus 1 is negative 9. So now we've got the right number, but it's the wrong sign. So what do I have to do now? Yeah, switch the signs. Make that a plus, make that a minus, and now you're good. You have to. There's no other option. So we get 2 times 5 is 10. Take away 1, gives me the 9. Perfect. So now we've got two linear factors. I'm going to set up a number line for 2x minus 1 and x plus 5. On that number line, I'm going to mark the zeros. So for 2x minus 1, what would you plug in for x to make that come out to 0? Oh, Blake? Yep, 1/2. So all I do is mark that one spot on the number line. 1/2. Okay, Kathleen, what would you plug in for x to make the second factor 0? Negative 5. Again, these aren't to scale. I'm just making two number lines. They're totally separate. Now, let's look at each one. If I plug in numbers smaller than 1/2, anything smaller than 1/2, like 0, what would I get when I evaluate? A positive number or a negative number? Emma? A negative. Now, if I plug in numbers bigger than 1/2, like 5, okay, what kind of number would I get when I evaluate there? Yep. Positive. Okay, let's do the same thing down here. If you plug in numbers smaller than negative 5 and evaluate, you would get what kind of number? Yeah. Negative. And if I plug in numbers bigger than negative 5 and evaluate, I would get positive. Okay, so we've made kind of a picture for each individual factor. Now I'm going to explain this last part. We have the individual number lines. Now we're going to combine them into one number line to get the final answer. So my final number line is for both factors. And on that number line, I put both roots. Negative 5 will go there. 1/2 will go there. And now we're going to determine the sign in each section. So we have 3 sections to figure out. 1, 2, 3. Let's start with the section where stuff is less than negative 5. Let's look at the top number line. If I plug in a number that's less than negative 5 into the top one, what kind of number do I get? So, Nathan?
You get a negative number?
Yep, I'll get a negative. So off to the side, I'm just going to keep track of that. So negative And now, Nathan, what about if I plug in a number less than -5 on the bottom number line?
It's also negative.
It's also a negative. And a negative times a negative would give me a positive. So if you plug in any number you want less than -5, you will always get a positive result using that to evaluate. Let's check the middle section. Between -5 and a half. So Gabe, if I'm between -5 and a half on the top number line, what kind of number do I get?
You'll get positive.
Well, -5 would be like over here, right?
Negative.
And then a half would be, so you're looking at numbers in there. So it would be a negative. So negative. And now let's check between -5 and a half and the bottom. So Natalie, what if I'm between -5 and a half on the bottom?
Positive.
Positive. A half would be like over here. So -5 and a half, it's positive. Negative times a positive, negative. So if you pick any number between -5 and a half, plug it into what I have circled, your answer will always be negative. Let's check greater than a half. Ashley, if I'm greater than a half in the top one, where am I?
Positive.
Positive. What about greater than a half in the bottom?
Positive.
Positive. So that's a positive times a positive, which is a positive. Now we can use that picture to answer anything they want to know. They want to know where we are positive. Where is the answer greater than 0? Well, go down and look. That happens in two places. Here and here. So we just have to write what the answer is. So you can pick any number from -infinity up to -5. Now I have to check if I can include -5. Can I include it? What do you think? No, it has to be, it's a strictly greater than. If I let it equal -5, well, that's where one of them came out to exactly 0. So I can't equal 0. The problem asked me to be greater than 0. So you can pick any number in the left section or any number in the right section. So from 1/2, again, you can't equal 1/2 because that would make it exactly 0. They said greater than 0. Whoops, I should always put a parenthesis. If you were looking at that and you're like, why did he put a bracket on infinity? You can't reach infinity. So that should have been a parenthesis. And that's the answer. So basically, you can pick any number you want except numbers between -5 and a half. Don't pick any numbers in there, but anything else. That's how you solve a quadratic inequality. Questions on that one? Let's try this one. So this one isn't a quadratic, this one's a cubic. But because we don't really know how to factor cubics yet, I've already factored it for you. So, first factor is x, the second one is x plus 3, the third one is x minus 1. Okay, so let's make a number line for each factor. Emma, for my first factor, the x, what would you plug in for x to make it 0?
0.
0, yeah. And if you plugged in numbers smaller than that, what kind of values would you get?
Negative.
Negatives. And if you plugged in numbers bigger than that, what kind of values?
Positive.
Positives, yeah. Okay, second factor, x plus 3. Rachel, what would you plug into the second factor to make that 0?
Negative 3.
-3. If you plug in numbers smaller than -3, right here, what would you get?
A negative.
You would get negatives. Bigger than -3 for x?
Positive.
Positives. If you're wondering, is it always negative on the left, positive on the right? Yes, as long as you don't do something like that. Because now you're flipping the sign of everything and that messes it up. But we usually don't have that. So last one, x would be 1. Plug in numbers smaller than 1. You're going to get negatives in that section, positives there. So now we make our combined number line and put all 3 roots on it in order. -3, 0, 1. So in numerical order. -3, 0, 1. So how many sections do I have to test here? 4. And they're going to alternate. They always alternate either positive, negative, or negative, positive, positive. They always alternate. So technically, once you find the first one, you can just alternate. But let's find the first 2 just to make sure we didn't make a mistake. Because if you find the first one wrong, then you're all messed up. So less than -3. How about Joe? Let's go to the first one. If I pick numbers that are less than -3 on the first number line, what section am I in?
Negative.
Yep. What if I pick numbers on the second number line, less than -3? Negative. And what if I pick numbers on the third number line, less than -3? Negative. So I end up with a negative times a negative times a negative. That's a negative. So the next section should be positive. Let's check. So now between -3 and 0. Okay, so Ryan, on my first one, if I'm between -3 and 0, what kind of numbers do I get?
Positive. Negative.
Negative, yep. On the second number line, if I'm between -3 and 0, what kind of numbers?
Negative.
Well,
-3.
0 would be over here.
My bad.
So you're looking kind of in there.
Positive.
Positive, yep. And then on the third number line, between -3 and 0?
Negative.
Yeah, you're somewhere over in here. -3 to 0. So now, if you were to multiply a negative times a positive times a negative, it would be positive. Great. So now I know this. That's what's going to happen. Does anyone need me to go through the third or fourth section? I just make this little chart off to the side and just keep track. That's what happens. So now, the question said, where are we greater than or equal to 0? What sections does that happen in? We'll just call them sections 1 through 4. Wait.
Sections 2 and 4.
Sections 2 and 4. Now, before we write our answer, let's go back up. And it says greater than or equal. So keep that in mind. So can anyone describe to me the numbers that are in section 2? How would you describe those numbers? Oh, Jacob?
I'm not sure. I'm a little lost.
Not sure? Anyone when I say section 2, do people know first like what numbers I'm between the values? Because then we have to write it as an integral, but let's just say what numbers we're between first. So Robin, what numbers am I between?
I'm between -3 and 0.
Right, now I just want to write what Robin just said as an integral. So I want to write between -3 and 0, keeping in mind that symbol. Yep.
Wouldn't it be bracket
Mm-hmm.
-3, 0, bracket?
Yep. So that's the second section. You can pick any number that's a closed interval between -3 and 0, or how would we describe the numbers in the fourth section? Because we are also positive there. Yep.
Parentheses 1.
Now, can we equal 0 though?
No.
Let's go back up.
Wait, no. Yes.
Yeah. With that symbol means you can plug in a number and get exactly 0, and it's okay. And if you plug in 1, you're going to get 0 times 4 times 1, which is 0. And 0 is greater than or equal to 0. So it is okay to use the number 1. So bracket, yep. up to infinity. And what symbol on that?
Parentheses.
Perfect. Now, if the question said, where are you less than or equal to 0? Well, it's just the other two intervals. From negative infinity to negative 3, and from 0 to 1. Again, all brackets on the numbers, always parenthesis on infinity. If they changed the problem and erased the equal to symbol, all I would have to do is put parentheses in place of all my brackets. Okay, any question on that one? That one had 3 factors, and again, something like that I would already have factored for you. Division, kind of the same thing. So mark your roots. 4. That one's going to be negative 2.5. And nothing else, nothing changes at all. Negative on the left. Bigger than 4 will end up positive. If you're less than negative 2.5, that's negative. Greater than 2.5, positive. Now, when I make my combined number line, how many sections am I going to have on it? Oh, that's yeah, we're going to have 3. We're going to have negative 2.5, positive 4. That creates 3 sections. So now we just have to check when we're less than negative 2.5. So Nate, if I'm less than 2.5 on the first number line, what kind of number is that?
It would be negative.
Yep. And if I'm less than 2.5 on the second one?
Isn't that also negative?
It's also negative. And now in this problem we're dividing. Well, same rules as multiplication. Negative divided by negative? Positive. So that's going to be positive, negative, positive. Now I just have to scroll back up, and do they want to know where I'm positive or where I'm negative? They want to know where I am negative or equal to 0. So that's going to happen right there. Any number between negative 2.5 and 4. Any question on that? All right. So if it's not possible to factor it, or it's really, really difficult, we can just graph it. All right. So we've already done problems similar to this, but I'll just show you how to do it. Put what's on the left in y1. Put what's on the right in y2. So we get x cubed minus 2x squared minus 5x plus 7. So that's the graph in blue. And I'm looking for where the graph in blue is going to be greater than or equal to the graph in red. Let's change the window. So there's my graph in blue. I want to know where that is greater than or equal to the graph in red. Now you'd have to find all the intersection points. Any questions on how to do the 3 intersections? No? Okay. So I'm going to assume that we can handle that part. So the answer, after you find the intersections, let's call this an intersection point. I'm just going to make up letters. A comma B. Let's call this one C comma D. And let's call this one E comma F. So you'd find all those values. Now, when you describe the answer, you're always focusing on x values. You're always looking at x's, not y's. So where is the blue graph above the red graph? Well, that's going to happen from there to there and there. So there's 2 sections that it happens in. you could pick any x value between a and c. So anything between a and c. Okay, well, you just have to find out what a and c are, and as long as you pick one between a and c, you're above the red. Or you could pick any value after e. Okay, whatever e is. Looks like it's about maybe 3, a little over 3. So anything a little over 3 or more, and the blue graph is above the red. So from E up. Okay. So once you find the intersects, that's the answer. That one is way too hard to try to factor because it's a cubic. I don't expect you to factor anything other than a quadratic at this point. So any questions on that idea? A little time consuming to find the intersections, but once you find them, it's pretty straightforward from there. Alright, so that graph that I just showed you in blue and in red, those are both polynomials. So most of the stuff in this section I've already mentioned at one point. So if you already know it and you don't think you need to write it down, that's fine. Okay, but basically, the way a polynomial works, it's kind of hard to describe it generically. That's what it looks like. So polynomials start out with the highest exponent, and then as you go down the polynomial, each exponent gets lower and lower and lower, till finally, the last number doesn't even have a letter. It's just a constant. So like 8x to the 4th plus 3x cubed minus 2x squared, something like that. The exponents go down. Now, sometimes you don't have every exponent. Like this has the 4, the 3, the 2, the 1. That's fine. 8x to the 4th minus 2x squared, you skip the cube. It's okay. But the exponents go down, and then in front of each letter is a coefficient. And that's basically what a polynomial looks like. The important thing is exponents cannot be decimals. They can't be fractions. They can't be negative. What do they have to be? Non-negative integers. Every exponent has to be a non-negative integer. So something like 8x to the 1/2, no, that is not a polynomial. Right? If I did 2x to the -3rd, nope, not a polynomial. Exponent has to be a non-negative integer. Don't worry about that. Just as long as you know the first thing, that's fine. Now, as long as you put it in what we call descending order, which means the highest exponent is first, and it goes down from there. That first term will tell you the degree of your polynomial. So the degree of that polynomial is 5. Now, that also assumes I don't do something like this. 0 times x to the 5th. If you said the degree of that polynomial is 5, now you're wrong. What's the degree of that polynomial? Yeah, it would be 2. Why not 5? I just said that the first term usually is the high, you look at the highest exponent, and that's the degree. 5 is the highest exponent. Okay.
Is it equal 0?
Because what?
Equal 0.
Yeah, the whole first term is going to equal 0, so basically why are you even writing that? You've wiped it out by multiplying by 0. So the first term is really negative 8x squared. Now, what if I wrote it like this? 2x cubed minus 5 plus x to the 6th. What's the degree there? Yeah, 6. For some reason, the person that wrote this didn't put it in descending order. So the highest exponent should always be first, but if it's not, look for it somewhere else, and in this case, that's a degree 6. Some polynomials, when they have a certain degree, have special names. The first 3 is what we generally use names for. So if the degree is 1, like something like x plus 6, that's a linear polynomial. If you graph it, it's a line. X squared minus 8, that's a quadratic polynomial. If you graph it, it's a parabola. And then 3x cubed minus 4x plus 6, that's just an example of a cube. And that degree, other than giving you a name, it tells you a lot of things about the graph. It tells you how many turns it can take. So we'll look at a couple things that it tells you right now. Now, one nice thing about the domain is that the domain for every polynomial is all real numbers. All of these. You can take any number you want and add 6 to it. You can take any number and square it. You can take any number and cube it and then subtract 4 times that value. Always. Okay, the domain is always all real numbers. So if you get that as a question, you shouldn't even think about it. Domain, anything you want. The range depends. Some polynomials go up and down forever. Some polynomials, like parabolas, only go up forever or down forever if you flip it. So the range depends. Okay, but domain is all real numbers. So we've talked about cubic functions. I think we've already even written this down, so really we don't need to. Cubic functions have a 3 as the highest exponent, and they look generally like one of those 4. Okay. This exponent tells you a couple things. If you put an x-axis in there, it tells you how many times it could cross the x-axis at most. It's not a guarantee it will, but it could. It also, if you subtract 1 from that number, tells you how many turns the graph can take. Again, can take, doesn't have to take. So this particular graph goes up, takes a turn down, takes a turn up. It turned twice. This graph looked like it kind of wanted to turn, but never really did it. Okay, so if you subtract 1 from the exponent, how many turns it could take. So that's a 4th degree polynomial. Highest exponent is a 4. I might have one like if you were graphing. Doesn't have every term in it. It's missing the cubed and the squared and the linear term. Just had the highest term and the lowest term. That's fine. Doesn't have to have every one of them. Just think of the other ones as zeros. How many times could this graph cross the x-axis? Up to. Yep. 4. How many turns could it take? Up to. Yep. Up to 3. So you can get kind of like a W shape if you put an axis in there. Now, if your axis, let's say this graph was shifted, instead of crossing 4, it might cross 3, like that, 2, or 0. Or actually, I skipped 1. You could also get 1 in there too. So you have 4, 3, 2, 1, or 0. So a lot of possibilities. And the W shape can flip over. It can be like less of a W shape. It could be more like that. That's still a 4th degree polynomial, just a little different. So let's graph that and see if we can find the domain and range. First of all, it's a polynomial. No negative exponents, no decimal exponents, no variables in the bottom. Variables in the bottom, that's a negative exponent. What's going to be the domain of that polynomial? Yeah? All reals. Always. Domain. All reals. range? Well, this has a W pattern to it. Let's graph it, but we know that the W pattern goes either up forever or down forever, but it doesn't do both. So we've got x to the fourth plus 5x cubed plus 2x squared minus 8x plus 1. Let's hit graph and see what it looks like. So it's got that W shape. We're not quite seeing the bottom, so let's just set the y min. I mean, it wasn't that far off the screen, so what do you think a good value would be? Oh, right.
20.
Negative 20?
Yeah, negative 20.
All right, so let's just try negative 20. I think that'll be fine. Okay, so does this graph go up forever, down forever, or both? Rachel? It goes up forever. Well, if it doesn't go down forever, that means it must bottom out somewhere. Where does it bottom out? Right there. If I go second calc minimum, I can find the lowest value that the graph ever hits. Whoa. Oh no, stop. Cancel. Abort. Well, yeah, it's going crazy. So, if somebody can do that for me, second calc minimum, I want to find that lowest y value. It's not that. I don't know, I can slide it. Does anyone have the lowest y value? Yeah. Roughly.
Negative 11.95.
Okay, so it hits negative 11.95. I forget, if it looked, kind of like something like that. So you find that lowest value, it's negative 11.95, and it's going to go up. The graph goes up forever from there. Okay. So fifth degree polynomials, I'm not going to get into it, but you can imagine. Fifth degree polynomials can cross the x-axis 5 times. So what we just found in that last problem was called a local minimum. Or we also have what's called a local maximum. Oh, my calculator catches on fire. So when I talk about a local minimum and maximum, I'm not saying that this is the highest value the graph ever hits. All that I'm saying is this is the highest value it hits in a certain area. Right? It's kind of like a mountain. You might say that a mountain, this is the highest point in a certain area. But then, you go to Colorado and they have mountains that are much higher than that. All right, so same idea. That's the lowest value that it hits in that area, not the lowest value that it hits ever. Right? So local maximum, point on a graph that is higher than all other points around it. Local minimum, point on a graph that is lower than all other points around it. So you could actually put maximum and minimum in the same thing. Just put point on a graph that is higher / lower than all other points around it. And same thing up here, just put local maximum / minimum. Because it's the exact same definition, you're changing one word. Any question on what a local maximum or minimum is? So we just went through finding one, but I didn't really get to show you because my calculator freaked out. So I'll try again. X cubed minus 4x. And the directions ask me to find the local minimum. Bless you. Okay, so right there is the local minimum. Second calc minimum. And I'm okay. Pick a point to the left, pick a point to the right, and do a guess. So they asked me two questions. What is the minimum? And where does it occur? So where the minimum occurs is the x value. It occurs at 1.15. So the min occurs when x is 1.15. And now what is the actual minimum? What is the y value? The minimum is negative 3.08. So where it occurs is an x value. What is it? Is the y value. So that's the local min. I'm not going to do the local max. It's exactly the same idea. Just second calc maximum. Not worry about that one. All right, so the last thing I'm going to just explain is what it means, and this should be mostly common sense, for a function to be increasing or decreasing. Well, increasing means it's going up to the right. Decreasing means it's going down. So this particular function is increasing from here to here. Okay? So the way we would describe it, from B to C. Now, when you describe where something is increasing and decreasing, don't use brackets. Because when you get at B, nothing's happening. At B, think of B as flat. Right when you get to B, it's perfectly flat. We're not going up or down. So where is the function decreasing? From what to what? Yep.
From A to B, C to B.
Yep. So the function is decreasing from A to B and from C to D. So I'll just write it that way. That's where it's decreasing. So look back up at the picture. As you go from increasing to decreasing, what happens? Increasing to decreasing. What do you call point C? Yeah.
Maximum.
A local maximum. Anytime you go from increasing to decreasing, you get a local max. How about if you go from decreasing to increasing? What happens there? Yep.
Minimum.
You get a minimum. So you get a local minimum. I almost said global. Global means like if you had a parabola, that's a global minimum. It is the lowest value ever. There's nothing any lower than it, ever. It's like the lowest. Local means it's the lowest value in a certain area. And okay, so that's the homework. The first part, that's on the sine pattern stuff. The second part, that's on polynomials. Nothing too fancy, basically finding mins and maxes. I think almost every question on page 149 is on the calculator. Or at least quite a few of them are. Okay, so we'll look at the homework tomorrow. We'll finish section 3.2 tomorrow. I will be after school if anybody's going to be on the AP field trip. Needs to take the test. Otherwise, you have 2 weeks to make it up. And then we have our last test before progress reports on Friday. People have been asking me about the homework grades. I have not put homework grades in yet. So once I put them in, then it will show you your accurate average.